All right, so we looked at in between the layers of a cross section so that it'll stay together. But really, we looked at like how much force it takes to keep the cross section together. And one of the ways that this thing is really important is for built-up shapes in flexural member. Sometimes you want to build a cross section out of a bunch of other parts. For instance, like you want to build an I-beam out of 3 plates. So you might take 3 steel plates, and you want to build an I cross section. And so what you got to figure out is how strong or how much weld do you need to connect these plates, and shear flow is the way that you would do that. Or maybe this I-beam that you get from the the plant that fabricated it for you is not enough, and you need a way to make this thing stronger, so that maybe one thing you want to do is you'll add or you'll bolt channel shapes to the top of this thing, so that you might end up with the cross section that looks like this. And you might bolt those here, right? You might bolt them, and you might have them at the top and the bottom, some bolted channel shape. Imagine this is going to be symmetric. Yes. Yes. And so, the question is, wow, I need this for the length of the beam, and the beam is, coming out of the page, if you will. The length of the beam is coming out of the page. And I got to know, wow, what should the strength of these bolts be? How many? What's the spacing that I need for these bolts? And the shear flow is the way that we are going to answer that question. And in fact, you might do it with wood, right? You might have like wood. Oh, look, I got brown. What's up? Anyway, here, bam. Right here, I got maybe I got some 2x4, or I got some plywood that I cut. So I can use that for the shear, and a little bit of 2x4s here and here. And I want to build this beam cross section like this. And I nail into the sides, boom, boom, or right here, and then boom, a little nails here, right? And then if I looked at the side view of this beam, what I might really see is that this beam would be acting like this. And I want to really know what are the spacing of these nails, or even the diameter of these nails that I need to hold this beam together and resist the load. Like, what is this spacing of the nails? And these are good, important questions for us to ask so that we don't over design or have not enough nails and have this thing fail prematurely, right? Another application for the shear flow is to find the shear center of a cross section. And the shear center is important to know, especially when you have like transverse loading for a cross section without a vertical axis of symmetry. What does that mean? That means, like, for instance, let's say I have a channel shaped cantilever, and I have it oriented like this here, and it's fixed to a wall back here. Yes. All right, so fixed to a wall back here. And what happens is there's a geometric centroid for this cross section. You see how this doesn't have a vertical line of symmetry? There's no vertical line of symmetry here. So here I have the centroid of my cross section right here. What's going to happen when I apply a load through the centroid, it'll end up causing bending and twisting or torsion. So we'll get some sort of combined loading condition because of the lack of vertical axis of symmetry. So you could use the shear flow to find what's called the shear center. And the shear center is some point, here I'll draw it in red, the shear center would be some point, some distance E away from the centroid that would represent the shear center. This dot right here might be the shear center for this channel shape right here. So that if I apply a load through the shear center, will only result in bending without twisting or torsion. And this load, I didn't draw it straight on purpose. As long as that load is applied in that plane through the shear center, I will just get bending. It could be biaxial bending, but there will not be twisting. What's up? All right, hopefully that was a useful introduction to shear flow, at least the derivation, and then a couple applications. If you can think of more applications, maybe put it down in the comments below. All right, take it easy. Shut your